Alright, so this video is going to cover general transformations of a graph. So what we're going to do is we're going to provide a name here to this graph. So just generically we'll call this f of x. So we'll say that this graph represents the function f of x. So we're going to do some general transformations. So let's take a look at the first one. So let's take a look at how I would shift this graph, just everything down 2 points. So the way you would write that, if I just want to shift this down, okay, down 2. So if you're moving something up or down, you're affecting the y value. So what you need to know is that f of x is what represents your y value. So in this case, I would say take all of my outputs represented by f of x, and I would say subtract 2 from all of them. So what this is telling you to do is essentially saying take all your y coordinates and subtract them by 2. So I'm going to go to my critical points, and I'm going to subtract all of their y values by 2. So my first critical point is at here. Now I don't look at the -5, I'm worried about the outputs, so I'm worried about up and down here. So the value at -5 is 0, so 0 minus 2 is -2. So my first point that I can plot is now -5, -2. The next critical point I'm going to go to is at -2. I notice that it switches its pattern. It switches the way it changes the type of line. So at -2, its output is also 0. So I'm going to take 0 minus 2, and I get -2. And then from there, what I can do is I can go ahead and connect those 2 points. Then I'm going to go to the critical values of the blue line. The critical values of the blue line, okay, are represented by anywhere that I have something that's significant. So this line that you see in blue, okay, is increasing all the way up until it hits the y-axis at 4. So the value here is 4. So 4 minus 2 is 2. So I'm going to plot that point because it's a critical value to 2. I'm then going to go to the next value, and the next value, it ends at 3. So that value subtracted by 2 is 1, and I plot this. And then all I'm going to do is I'm going to draw the same exact thing as best as I can. I'm going to draw the same exact curvature of this line going up and coming back down, and it looks like such. And the next thing I'm going to do is I'm going to go to the green one. So in green, okay, in green here, I'm going to go take a look at this particular function, and I'm going to do my best to draw this particular thing. So what I'm going to get here is I'm going to try to do the best to drawing this green one. So I'm going to draw the green one. I notice its first critical value starts at +1. Well, 1 minus 2 is -1. So I just need to note that it's an open circle there, so I'm going to put an open circle. And then I notice the line has a slope. I'm not really worried about that because I'm only worried about connecting 2 points. The 2 points that I connect will automatically make that slope for me. So I'm going to go to the end, okay, of this green line. I'm going to follow it to the end, and at the end, its value is -2, and -2 minus 2 is -4. So I'm going to go ahead and plot that point at -4. So what I get there is connecting them is I get that line. So what this new graph represents, the one that I drew in here, would be a shift down 2 units, and its expression is noted by subtracting 2 from your actual function. So let's take a look at another example. So another example could be, instead of shifting it up or down, I could shift it left or right. So shifting it left or right will be noted. So I will say, let's shift this graph. Let's go with 3 units. 3 units left. So what's important about shifting something 3 units left is I don't want to change. If I move something left, okay, so if you notice, if I move this point left, notice what happens is that its output stays the same. So in function notation, we represent the output by f of x. So what I'm not claiming to you is I want the outputs to remain the same, but I want all of the x coordinates to go left too. So if I take a look at this, okay, this current value is going to be -1. Well, the only way I can get the function that I have seen here to represent -1, okay, is going to be by the only way I can get an output of 3 is by plugging in this -1 down here. So whatever I write in my new function, okay, so this new function that I'm going to create, just so you understand, I want the output to be the same, but I want the x value to start over here. So the question is what do I have to do here? And what I'm going to do is I'm going to say, okay, the value of -3, okay, let's say I use that -3 because that would be where the new point is going to end up. Well, what's the difference between -3 to -1? Well, in this case, that's a value of +2. So inside of our function, we're actually going to get x plus 2. And what this denotes is it denotes a shift to the left. Because now if I plug in -3 into here, okay, I end up getting this f of -1, which is what I wanted. And why did I want that? It's because I'm trying to keep the output the same. When I shift something to the left or to the right, the output remains the same. So that's how this graph will look. So this will be denoted, if I want to shift something left or right, okay, it will be denoted simply by writing f of x plus 2. Notice that the plus 2 is on the inside. So what you can also notice is that when I have a plus, the plus is actually shifting something to the left. So I wrote +3 in the beginning, and I meant to write +2. So I just realized I did that. I apologize. Shift 2 units to the left. So vice versa, if I wanted to shift it to the right, the operator on the inside would be subtraction. So I'm going to now go ahead. I'm going to shift every point here to the left too. So just notice that this +2 is going to shift everything to the left. So I take every point and I'm going to shift it left. So right here it's at 0, 0, shift 2 to the left. There's a critical point, and then I take the other one. Okay, so I'm going to go back to this problem. And I'm not going to choose a value that's right in the middle of the line here. Okay, in this case I'm just going to use critical points. So another critical point will be this value, shifted 2 to the left. It ends up here. So I'm going to go ahead and plot that point. Plot it. I'm going to go to the end of this curve, which is down here at -2. -2 shifted to the left puts me at -4. So I'm going to go ahead and draw that piece in there. So as best as I can, in black, there's that piece. If you notice, it's just shifted 2 to the left. And all I have to do is mimic that. So I take this open circle, move it to left, take this closed circle down here, and shift it to left. And I get this point here. And all I'm going to do is go ahead and graph the line. The next thing is the red piece. Well, the red piece is everything shifted to the left. So I start here, and I end up over here, 2 units left. And what you have is a graph that was simply shifted to the left. So remember, when the operator on the inside says plus, it's a shift left. And if the operator on the inside were to say -2, I actually would have taken this graph, everything here, and shifted it to the right. Because you have to think about, what do I have to do to this value so that it ends up evaluating the f function with using the value of 1. Because remember, we don't want the output to change, we want the output to remain the same. So let's do another graph where we might have something else happen. Another possibility is we could have this thing called a vertical stretch or a vertical compression. So a vertical stretch or a vertical compression is when you take a point and you actually multiply it by a value. So one of the ones we can do here is we can change our f of x, we can change its output. So if we want to change our output not by just moving it up or down, we can change the output by multiplying it. So in this case, I'm going to say let's multiply all of our outputs by 1/2, and our outputs is denoted by this idea of f of x. So what this will do is we'll take a look at this. So this is a 1/2. So let's multiply every output by 1/2. So I'm going to go to my critical values, and I'm going to multiply them all by 1/2. So again, because I wrote f of x, you just need to know that I'm talking about the output. So I go to the output at -5, which is 0. So 0 times 1/2 is 0. So it plots right there. I go to the critical value at -2, which is 0. So 0 times 1/2 is 0. I then go to the blue line, go to my critical point, which is at the top, which is 4. 4 times 1/2 is 2. And I go to my next critical point, which is at 3. 3 times 1/2 is 1.5. And then what I'll do is I'll do my best to draw it connecting those points. So there's that. So then I'll go to the green. And the green, I go to the critical output. So at 2, it has an output of 1. 1 times a half is 1/2. Go to the next output, which is going to be at 5. 5 has an output of -2. -2 times a half is -1. And I put a closed circle, and then I connect them. So there what you quickly have is some general transformations of a graph for this function. So that will conclude this video for now. And yeah, I hope that helps with starting whatever it is you're trying to do.